All right, putting my mug back in the corner here. I already made this video once and I blew it badly because I got into the whole third law thing. And this is, we're only dealing with Newton's second law. Now, they talked about the impulse, the change in the impulse, or what an impulse is. And I just wanted to, we'll talk about that more later when we're looking at it. Actually, in chapter 4, we talk about it quite a bit. And so I didn't want you to be too afraid of it. All right. And the other thing too is I found out when I've been editing this text platform or whatever is that it's really annoying when I start clicking on this thing and I'm recording. You hear every little click and every little and I'll try and cut those down. All right. So, but listen, I just wanted to show you Newton's second law. And not to be worried about the impulse. We'll get to that in chapter 4, and I'll also talk about it a little bit more down the line when we get to the third part of part 3 of chapter 2, which is Newton's third law, because the force on one is equal to the force on the other. But this one, we're looking at Newton's second law. So let's go ahead and turn this off. All right, so here's an annoying click for you. Let's turn the ladybug. Let's turn my ladybug back on and click that off. We'll close that. And it should come on pretty quickly. Okay. Should come on pretty quickly because I don't want these to be more than 4 or 5 minutes long, these little movies. And if I'm spending 3 minutes waiting for the equipment to come on, then, oh, it's playoff season. Well, it's getting close to the NFL playoff season here in the United States. I know the Top Hat folks are up from Canada, and they have their own brand of football up there. But in broadcasting here from Kansas City, home of Patrick Mahomes, the Chiefs have established themselves firmly as maybe the 4th best team in the NFL, even though don't tell that to any Kansas City fans. All right, we're the best there is. Well, it sure seems to me like whenever you play somebody good, you lose. So let's see. We got the Rams. We got the Chargers, the Patriots. Even though the Patriots are faltering now, our 3 losses: Rams, Chargers, Patriots. We might be the 4th best team in the NFL, but that's neither here nor there. So let's talk a little bit about impulse here. Okay. So this is on. Should come right on. Should come on. It should come on. Why aren't you coming on? I don't understand. Oh, there we go. God, this is fun. All right, hear it now. Because I've been watching these, so I understand how annoying this is now. It's probably even more annoying me pointing out how annoying it can be. All right, so hold on a second. One more click. A couple more clicks here. And let's get this set up so you can see it. So Newton's second law. That's what we're talking about here. Newton's second law. So F equals ma. And that's the object. So if I've got this football here, okay, got this football here, and Lucy's not going to pull it away from me, and I come in to kick it. So, and I'm sorry, I've got to go old school Lou Groza style kick here with his platform shoes on. All right, he's going to come in and kick it. Bang! That's the impulse that they're talking about right there when those 2 forces hit. All right, and boom, we're just talking about the force that the foot applies to the ball here. So the force of the shoe on ball. All right, so that's what we're talking about, is equal to the mass of the ball if it moves, mass of the ball times the acceleration. All right, times the acceleration. Now, we learned that explosion, that time that it hit, t, is equal to 0.008 seconds. That's 8 thousandths of a second. Okay, that's how long that impact, this acceleration lasts. From right here, this point, this is the impact, lasts 0.008 seconds. So what does that mean? That means that the change in velocity, the initial velocity of the ball is 0. And then the ball takes off. The final velocity is equal to 60 miles per hour on average for an NFL kicker. is 60 miles per hour. We got to convert that SI units. SI units. We need to go meters per second. You can Google it, or you can just do this quick and dirty factor. This is my miles per hour to meters per second factor. And it comes, where does it come from? It comes from 1,609 meters divided by 3,600 seconds. This cancels out the miles, this cancels out the hour, and you get 0.447. That's where that comes from. So anytime you see miles per hour, multiply by 0.447 for the rest of this course, and you'll be fine. Or you can Google the thing. You know, I don't want to waste a bunch of time doing conversions, even though that's very important, because you got to know what units you're talking about, as we spent chapter 1 talking about. So, and when we do that, when we find the final velocity, we get 28.6 meters per second. So that comes out to be pretty nice then. And also the impact, you've got an average force that takes place. We're just kind of calling it the force. You know, we're just looking at the average force times delta t is what they're saying. Times that change in time is equal to the mass of the ball times its change in speed. Well, look what happens. I put that average force times the mass, change in v, divide delta t by both sides. This goes away. Delta t. Change in velocity over change rate of velocity over time is equal to acceleration. This is all a bunch of fancy notation, but that's all it is. So, so can we take 28.6 minus 0, because the change in velocity is equal to v final is minus the initial velocity. I also forget that a lot of you that are brand new to this don't understand subscripts. This means the starting velocity, this little 0, this little f means the final velocity. And when we do a change, we subtract those two. 28.6 minus 0, I can do that. I don't even need a calculator for that. Divided by 0.008. Now be careful. Sometimes you'll have another number here. So make sure you put this in parentheses on your calculator. And so you go parentheses on your calculator, 28.6 minus 0, close parentheses, just to practice, divided by 0.008, and you're going to get what I call a BAN, a big-ass number. But no, you're going to get a large force, because it's a pretty substantial change in velocity over a very, very, very dinky time. Because when we divide, if we have a number and we divide by a real dinky number, we get a huge number. I'll just show you on my calculator real quick, and then we'll let this go. All right, because watch. If I take, clear. If I take 100 divided by 50, I get 2. If I take 100 divided by 0.5, I get 200. If I take 100 divided by 0.000004, watch this. Big number. All right? Like a quintillion. No, I have no idea. So I would just call that 2.5 times 10 to the 8, 10 to the 9 times 10 to the 9. All right? Out here. That's the explanation for that.